Hi, so today I will finish this particular chapter. So what is left with this chapter is the division of polynomials, the factor theorem and remainder theorem. So first off, we look at the division of polynomial. Before we learn how to do it, actually it's quite easy. Let's define what is a polynomial first. So a polynomial is a function that looks like this form: a to the power of n x, a sub n x to the power of n, a sub n minus 1 x power n minus 1. You sum every terms until a1 x and then a0. So for a polynomial, there's a few things that you need to know. The list of numbers, let's say an minus 1 up until a1 a0. So these are what we call as the coefficients. If you see an, so an is the one with the highest power coupled with x with the highest power, sorry. So an is what we call as the leading coefficient. N will be the highest power of x, and that is what we call as the degree of polynomial. So what is the division of polynomial all about? Is trying to show you how two functions can be divided together to give you the quotient. So if you remember, like for example, 5 divided by 3. So this is a fraction, right? So the one on top usually, not usually, the one on top is what we call as the dividend. Let me just rewrite this. So I'm taking this as one example. The one on top is what we call as the dividend. The one at the bottom is what we call as the divisor. And then in this particular example, we can write this as 1 plus 2 over 3. Right? So this will be called the quotient, and the number 2 over here is what we call as the remainder. So the key idea of division of polynomial is to make use of all these concepts. So if let's say you have a polynomial, okay, by the way, if let's say you have 6 over 3, you get 2. So we call the number 6 is a factor of 3. Sorry, 3 is a factor of 6. I reverse the direction. So in this case, we call 3 is a factor of 6. So when there is no remainder, then your divisor is also a factor. So in this case, we just borrow all the terminologies. If you have fx divided by gx, and this gives you qx, rx divided by gx. So in this case, fx will be a dividend, gx will be a divisor, qx will be a quotient, rx will be your remainder. So let's look at one particular example on how we can do the division. The idea for division of polynomial is the same as how you would do the long division. So like for instance, let's say 5/3. The long division method is that you write the value 1, for instance, 1 multiplied by 3, you get 3, and then 2 will be your remainder. So the same way, let's look at one example. Use our algebraic division to show that 2x plus 1 is a factor of 12x cubed plus 16x squared minus 3x minus 4. Hence, solve. Sorry, I should put. Yeah, sure, why not? Hence, solve the equation. So what we would do is to write down the whole polynomial. Let me move this. Yeah. So then you have 2x plus 1. So use algebraic division to show that this is a factor. It means that when you perform the long division, at the end there should be no remainder. So the first step is to multiply to 12. So you get 6x squared. So you have 12x cubed. So 1 multiplied with that, you get 6x squared. So then for this level, put a minus sign. So 12x cubed minus 12x cubed becomes 0. 16x squared minus 6x squared, you get 10x squared minus 3x minus 4. So the second one, you need to multiply with 5x. So 2 times 5 is 10x squared plus 5x. So minus again. So now you have minus 8x minus 4. So you multiply with minus 4. So you have minus 8x minus 4. And this divides perfectly. There is no remainder. So this is how you show that this is a factor of the given polynomial. Hence, solve the equation. So 12x cubed plus 16x squared minus 3x minus 4 equals to 2x plus 1 multiply with 6x squared plus 5x minus 4. So this is a quadratic equation, so definitely you know how to factorize that. Plus minus. So so this should be, let me think about this. So that should be 3. Hmm. Okay, sorry, I see it now. So it should be 3 and 4. Hmm. If not mistaken, that will be this. Yeah. So you would get minus 3x, big X. So then, yep, this will be 2x plus 1, 3x plus 4, 2x minus 1. So that's how you factorize the whole equation. So usually for division of polynomial, you are just going to do this long division and that's it. So now let's go into the factor theorem. So what factor theorem tells you is also quite simple. If you look at this particular equation that I wrote just now, so factor theorems tells you what happens when there's no remainder. So in this case, we can just erase the remainder part. And when there's no remainder, meaning that your gx is a factor, so then you know that your fx equals to the quotient multiplied with gx, right? So if you look at the example just now, so this is the factor. And what happens when you substitute, let's say your factor is of this form. So what happens when you substitute a inside? So basically, when you substitute x equals to a inside, f of a will be equals to q of a multiplied with g of a. And your factor is g of a. If your factor has x minus a form, then when you substitute a inside, this part goes to 0, right? So it means that your f of a is 0. So if your factor is of this form, then when you substitute x equals to b over a, you will notice that the right side still goes to 0 because of your factor. So this part still goes to 0. So from these two cases, we can summarize the factor theorem as if you are given for a given polynomial, let's say px. So if p of a equals to 0, then x minus a is a factor of px. If p b over a equals to 0, then ax minus b is a factor of px. So that's basically the whole idea of factors theorem. There is another theorem called remainder theorem. So I will explain what is remainder theorem, and then we look at 2 examples, and then that's it. So let's paste that equation again. So this time, let's say you have remainder. So this equation tells you that when you multiply everything, you get something like this. So if your gx is of this form, then you notice that when you substitute x equals to a inside, so I won't write this. So when you substitute a inside, the one that multiplies with gx becomes 0. So you are left with your remainder. If your in this case we can't call it factor, we can only call it divisor. So if your divisor looks like this, sorry for the mistake of terminologies. So if your divisor looks like that, then when you substitute b over a inside, again the same thing, this particular term will just become 0, and you are left with this. So then you similarly you can draw the same conclusion. So for a polynomial px, if it is, or rather if the divisor is of this form, then p of a is the remainder. If the divisor is ax minus b, then p b over a is the remainder. So that's the remainders theorem. So now let's look at 2 examples. One uses factors theorem, the other one uses remainders theorem. So given that x minus 1 and x plus 2 are 2 factors of x4 minus x3 plus px squared minus 11x plus q. So the first part, find p and q. So then it's easy. When x equals to 1, you know that when you substitute 1 inside, the whole equation has to become 0. So 1 minus 1 plus p minus 11 plus q equals to 0. So here you have p plus q equals to 11. So that's your first equation. when x equals to minus 2, 16 plus 8 plus 4p plus 22 plus q equals to 0. I hope I substitute everything correctly. So this means that 4p plus q equals to minus 46. That is equation 2. So you have a simultaneous equation. So 2 minus 1, that will give you 3p which is minus 57. So p will be minus 19. So then minus 19 plus q equals to 11. Q will be 30. So let's look at part B. Factorize the equation completely. So now we can do this. X minus 1, x plus 2 equals to x squared plus 2x minus 1x plus x minus 2. So we do the long division. Probably not enough space. So over here you have x squared plus x minus 2. Whole equation is x to the power of 4 minus x to the power of 3 minus 19x squared minus 11x. Q is 30. So then over here you have x squared to get x to the power of 4 plus x to the power of 3 minus 2x. So probably I should move the whole long division down so that my equation does not get cut off. So you have minus 2x cubed minus 19 plus 2 minus 17x squared. Okay, minus 11x plus 30. So then what you need is minus 2x. So you have minus 2x cubed minus 2x squared plus 4x. So you have 15x squared 15x plus 30. So the last one is quite obvious, minus 15 so it completely factorizes. There's no remainder. So now you know that your whole equation can be factorized into x minus 1, x plus 2, So the other two you can find out immediately. So you have x squared over here minus 15 minus 2x. 3, 5 minus 5x, 3x. So the last two factors will be x plus 3, x minus 5. So that will be your answer. This one uses factor theorem. Let's look at our last example. Given that p of x is x cubed plus ax squared plus bx plus 2. So x minus 2 is a factor of px when px is divided by x plus 1, the remainder is 21. So part A asks you to find A and B. So the first one, you can use the factor theorem. Substitute x equals to 2 inside. So f2 will be equals to 0. 8 plus 4a plus 2b plus 2 equals to 0. So let's factor out. 4a plus 2b equals to minus 10, or 2a plus b equals to minus 5. So that will be our first equation. Second equation, when it is divided by x plus 1, remainder is 21. So it means that when you substitute x equals to minus 1 inside, you get 21. This is remainders theorem. So you just put it inside. Minus 1 plus a minus b plus 2 equals to 21. So a minus b equals to 20. So then 1 plus 2 3a equals to 15. So a will be equals to 5. So 5 minus b equals to 20. B will be minus 15. So part B, as usual, solve the equation px equals to 0, for instance. Okay, so then what you will need to do is to write this. So the whole equation will be x cubed a is 5 plus 5x squared, b is minus 15 minus 15x plus 2. So this is your polynomial, and then you are given one of the factor is x equals to 2. So then you can do the long division. So remember that you cannot use x plus 1 because it doesn't factor out perfectly. So you will need to multiply x squared over here. You get x cubed minus 2x squared. So have a minus sign. 7x squared minus 15x plus 2. So you multiply with 7x. So you have minus x plus 2. So you have minus 1. So then your px equals to 0 results in x minus 2 x squared plus 7x minus 1 equals to 0. And from the look of it, it does seems like b squared minus 4ac won't be equals to something you can square root with. So I will just directly use formula at that point. So x will be equals to minus 7 plus or minus square root of 49 minus 4ac, so is plus 4 divided by 2a, or x will be equals to 2. So your final answer should be minus 7 plus or minus square root of 53 divided by 2, or x equals to 2. Might as well not use or. So those are your solutions. So that's all for this chapter. Sorry for dragging too long. Thank you.